Hey guys, let's continue. So today we'll be looking at Cauchy-Euler DE of second order. So up till now we have been looking at constant coefficients. Now let's look at variable coefficients. So for example, your general DE looks like this: x square y double dash plus a naught x y dash plus a1 y is equal to fx. So how we're gonna tackle this is we're gonna replace x with e raised to z, which means that z is ln x. Now remember, this z is a variable created by us, so it should not be there in the final answer. Wherever you have z, replace it in the end with ln x. So your equation basically becomes, this equation becomes x square d square plus a naught xd plus a1 times y is equal to fx. Now what we will do, as we did before, we're gonna write d by dx as d, but also we're gonna write d by dz as theta. So these are just notations, please don't get confused. So dy becomes dy by dx, which you can write as dy by dz times dz by dx. And what is dy by dz? It is theta y, and dz by dx is the differentiation of z with respect to x. So the differentiation of ln x is 1 by x. So if we cancel out y, we'll get theta is equal to xd. Remember this. Similarly, let's find what d square is. So d2y upon dx2. This is basically d by dx of dy by dx, right? So we can write this as d by dx of dy by dz times dz by dx, as we did over here. So this becomes d by dx of dy by dz times 1 by x. So let's apply the product rule to this. This is the first part, this is the second part. So we're gonna ignore the first one and differentiate the second one, that is minus 1 by x square. And then we're gonna ignore the first one, and the second one becomes d by dx of dy by dz. I've simply applied the product rule to these two. So let's look at this term first. Let the 1 by x be outside. So what does it mean d by dx of dy by dz? We can simply apply chain rule over here. So that would mean d by dz of dy by dx multiplied by dz by dx. This is nothing, this is basically chain rule applied to this part. And your second part is minus 1 by x square dy by dz. This is this part. So what was this? This was d2y by dx2. So this was d square y is equal to 1 by x theta times theta y multiplied by 1 by x minus 1 by x square theta y. Remember guys, d by dz is theta. So let's just simplify this a little bit. 1 by x square theta square y minus 1 by x square theta y. So d square y is equal to 1 by x square theta square minus theta times y. So let's cancel out the y. So what do you get? You get x square d square is equal to theta square minus theta, or theta times theta minus 1. Remember this as well. So your differential equation basically gets converted into theta square minus theta plus a naught theta plus a1 times y is equal to fx. So these are a lot of notations, but once you do some examples it will become more clear. So let's start. So for example, let's take this question: x square y double dash plus 4x y dash plus 2y is equal to x square plus 1 by x square. So this becomes x square d square plus 4xd plus 2y is equal to x square plus 1 by x square. Now again, x square d square was theta square minus theta, plus 4 times xd was theta plus 2 is equal to, now x was e raised to 2z, so x square becomes e raised to 2z plus 1 upon e raised to 2z. So what do you get finally? Theta square minus theta plus 4 theta plus 2 y is equal to e raised to 2z plus e raised to minus 2z. So you get theta square plus 3 theta plus 2 y is equal to e raised to 2z plus e raised to minus 2z. Now you can basically solve this as we have been doing with our constant coefficients. So first of all, we're going to find the CF. Just use this and replace theta with m. So m square plus 3m plus 2 is equal to 0. This is m plus 1 into m plus 2 is equal to 0. So m1 is equal to minus 1 and m2 is equal to minus 2. So your CF or your YC becomes C1 e raised to minus z plus C2 e raised to minus 2z. Remember guys, your equation now is in z. So do not write x over here, make sure it is z. In the end, we will change z to ln x as we cannot leave the answer in z. So for PI, again, you can use any of the methods, any of the two methods that we've done. So I'm going to go with undetermined coefficients. So this is the given RHS, so I will assume PI accordingly. So let's assume your YP as A e raised to 2z plus B e raised to minus 2z. So now again we have the problem of linear dependency. This term is similar to this term, so we will multiply this with z. So your YP becomes A e raised to 2z plus BZ e raised to minus 2z. So now let's differentiate. Yp dash becomes 2a e raised to 2z plus b, here we have to apply the product rule. So ignore z, minus 2 e raised to 2z minus 2z, and then ignore e raised to minus 2z and differentiate z, which is 1. Now let's find yp double dash. So this becomes 4a e raised to 2z plus b. Again, let's ignore z and differentiate this. This becomes 4e raised to minus 2z plus, let's ignore the second part, differentiation of z is 1, and for this it becomes minus 2 e raised to minus 2z. So let's simplify this a little. 4a e raised to 2z plus b 4z e raised to minus 2z minus 2 e raised to minus 2z minus 2 e raised to minus 2z. So this becomes 4e raised to 2z plus 4b z e raised to minus 2z minus 4b e raised to minus 2z. You can add these terms. So this is your yp double dash. So now let's plug these into the original equation, which was this equation right here. So this is basically, we can write this as y double dash plus 3y dash plus 2y is equal to e raised to 2z plus e raised to minus 2z. This is the equation. So now let's go ahead and plug the values into this equation. So it's y double dash, that is this one, 4a e raised to 2z plus 4b z e raised to minus 2z minus 4b e raised to minus 2z plus 3y dash plus 3y dash, this is our y dash, 2a e raised to 2z minus 2bz e raised to minus 2z plus b e raised to minus 2z plus 2y, and this is our y, a e raised to 2z plus bz e raised to 2z is equal to this. So now let's simplify this. 4a e raised to 2z plus 4b z e raised to minus 2z minus 4b e raised to minus 2z plus 6a e raised to 2z minus 6b z e raised to minus 2z plus 3b e raised to minus 2z plus 2a e raised to 2z plus 2b z e raised to minus 2z. Is equal to e raised to 2z plus e raised to minus 2z. So we can add these terms. This gives us 12a e raised to 2z, 4 minus 6 plus 2, so these get cancelled out, minus b e raised to minus 2z is equal to e raised to 2z plus e raised to minus 2z. So the coefficient of e raised to 2z here is 12a and here it is 1. So 12a is equal to 1. That means a is equal to 1 by 12. Here it is minus b and here it is 1. So minus b is equal to 1. That means b is equal to minus 1. So your yp becomes 1 by 12 e raised to 2z minus z e raised to minus 2z. So your final y will be yc plus yp. Your yc was calculated as this. So y is equal to c1 e raised to minus z plus c2 e raised to minus 2z plus 1 by 12 e raised to 2z minus z e raised to minus 2z. Now remember guys, we cannot leave the answer in z, so we have to convert z back to x. So as x was e raised to z and z was ln x, let's make the changes accordingly. So y is equal to c1 x raised to minus 1 plus c2 x raised to minus 2 plus x squared by 12 minus ln x multiplied by x raised to minus 2. So this is your final answer. If you guys have any doubts, leave them in the comment section and I'll answer. Thank you.